So let's try to solve this one. So we got tan theta minus 3 cotangent theta equals 0. I'm trying to solve this, but it's weird because it's not the same trig function. So I'm going to go ahead and rewrite it with sine and cosines, so that way I can try to get same trig function. So that way, so do the same thing that you did when you were just simplifying these or trying to prove these. So I'm going to get sine of theta over cos of theta minus 3. Cotangent is 1 over tangent, so it just flips to 2. Cos of theta over sine of theta. That's going to equal 0. I'm going to find a common denominator. So I'm going to get sine squared theta, because this is going to multiply times sine theta over sine theta. This one will multiply by cos theta over cos theta. So sine squared theta minus 3 cos squared theta all over sine theta cos theta equals 0. Now here's the difference between trig identities and actually solving. Trig identities, we were trying to get the one side look exactly like the other, and we could play with them, but we couldn't move stuff across the equal sign because we weren't solving for anything. Here we're actually solving, so we can use equal sign like an equal sign. I can go ahead and, well, get rid of my denominator. Sine theta cos theta. I have to do the same thing I always do, make sure I don't get undefined when I plug things back into the original. But I have to do that whenever I have fractions anyways, so that's okay. So if I multiply both sides by that, cancels, I'm going to get sine squared theta minus 3 cos squared theta equals 0. Okay, so this is a little better, but I still have two different trig identities in here. Well, hopefully you remember the one that I think you should remember. Sine squared plus cos squared equals 1. So I'm going to go ahead and solve this for sine just because I see it first. Sine squared equals 1 minus cos squared. Guess we'll throw in some angles so we have them, theta. So if I do that, 1 minus cos squared theta minus 3 cos squared theta equals 0. Combine like terms, 1 minus 4 cos squared theta equals 0. And now I actually can just solve for cos. So I'm going to add 4 cos theta to both sides. So 1 equals 4 cos squared theta, 1/4 equals cos squared theta. Therefore, cos theta, if I take square root of both sides, is going to equal plus or minus 1 over square root of 4 is 2. So I'm looking for everywhere that cos is 1/2, positive or negative. So I'm going to go back to my chart. Cos is 1/2 at pi over 3. So I'm looking for the pi over 3 set. So I'm going to again set up unit circle. And I'm going to say theta equals pi over 3. So that would take care of cos being here. If I just add pi to that, I'm going to get cos over here, which is going to be one of my negatives. So I'm just going to add pi k. So I still need these set. So over here, this would be pi over 3 away from pi. So this is pi, so 3 pi over 3. So this one would be 2 pi over 3. So 2 pi over 3. And again, because I'm looking for all of them, I'm looking for them in every quadrant. If I just add pi to it, I will get it in my fourth quadrant. So plus pi k. Usually we add 2 pi k because we're going all the way around the circle. Here, we really only need to go halfway around the circle, then halfway around the circle again, then halfway around the circle again. So we're just adding pi k each time. Okay, so these are all the solutions for tan theta minus 3 cotangent theta. I said before we need to check and make sure they don't make the denominators equal 0 because we can't have undefined terms. Well, sine of pi over 3 is not 0, cosine of pi over 3 is not 0, nor 2 pi over 3. So we're pretty much set.